Hello everyone, my name is Mika Wan. I'm a doctoral student at Carolina Health Informatics program. Today we are going to talk about data visualization, which is essential to data understanding and human data interaction before and after you conduct a data analysis. In today's videos, we will first be talking about what data visualization is, why it is important, and why should we use it. Then we will talk about some utilizations, like what can we do with data visualization. We have a demo project for you to understand the whole process of data visualization. We will go through it step by step. And lastly, we will introduce you to some of the tools of data visualization. As our course is mostly based on Python, knowing the Python packages capable of generating good visualization is very important for you to understand our code in other modules later. It's also important for you to integrate your own visualization into a project in this course. We will also cover some other tools and softwares that are popular in generating fancy data visualizations for you to explore. Okay, so what is data visualization? Data visualization is the presentation of data in a pictorial or graphical format, which enables decision makers to see analytics presented visually, so they can grasp difficult concepts or identify trends and patterns. With the rise of big data upon us, we need efficient tools to help us interpret the rapidly growing data. As data analytics reveals us the fact behind the data, visualization gives us, as human beings, an intuition visually on how the data is actually related to the fact. Data visualization is not exclusive for digital era. It has been existing for a long time. The earliest and the most obvious example of data visualization projects are maps. Then you have the pie charts, which first showed up in the early 19th century. A few decades later, Charles Joseph Maynard used statistical graphs in order to map Napoleon Bonaparte's Russian campaign of 1812. This visualization, as shown on slide, combined multiple metrics. The number of troops indicated by the yellow and the black blocks, temperature as shown on the bottom of the map, and distance and directions as you can tell by reading the map from left to right, and more. Why data visualization is so important? You might have a hint from this slide already. From this map, we can easily see where and when did the march start, which cities did the army pass through, the number of casualties at each stage, and where did they decide to retreat. From the visualization, we can tell that the plummeting temperature on the returning journey could be an important factor that caused death. Through a visualization, we can understand data much intuitively, as that's how human beings perceive information. So now we know data visualization is an easier way for us to perceive information, but to be more specific, why should we use data visualization? The first purpose is to explore. Before we conduct a real analysis, we'd like to have a general idea of our data so that we can roughly know if we are on the right track of answering our research question. Data visualization is also helpful with later data analysis. For example, you like to see if the two variables, like GPA and the horoscope of students, are correlated. The first you can draw is a scatter plot for these two variables. If you find that the dots are all over the place, you may expect that these two variables are totally independent of each other. However, as shown in the plot for living area above ground and house price on the right side, you can see that there are some patterns embedded. It could be linear or nonlinear. Then it will be a good idea to conduct different analysis to review that pattern. Also in machine learning, we can also use a chart to monitor the learning process of our model and make sure it has been making progress to optimize the results. Another usage of data visualization is for the communicative purpose, presenting analysis findings, representing patterns, or explaining complex results. That is to say, after you finish your data analysis and you are trying to present your result to your audience, it is better to show them a real chart instead of just say something like, we found that students' weight and height are somehow positively correlated. Also, as you can see on the bar chart, a lot of information is embedded. From the chart, we can see the revenue of each mall, their ranking, the percentage of each type of revenue, and so on. It's going to take a lot of time if we'd like to convey the same amount of information using narrative descriptions. And usually, such a description will be more confusing than showing a chart. Okay, so now let's see how exactly can we make a data visualization. The first use of data visualization is data comparison. For comparing data side by side, bar chart is a good choice. The following example shows the top 10 products by revenue in two regions. From the chart, we can easily tell the difference among the products as well as between the two regions. Besides bar charts, we also have stack charts and radar charts that can help us with comparing data. The following slide will have more details about those two relatively more rare charts. Percent stacked area chart consists of several area series consecutively stacked on the top of each other. Stacked area charts should be deployed under the cases only if there are more than two series represented. In a radar chart, each variable is represented on axis. All axes use one scale and are arranged radially within the same distance from each other. There should be at least three axes. Well, too many axes can make a chart illegible as well. For exploring the composition of data, pie chart and tree map are good choices. The following picture shows the operating system market share of consoles in the pie chart. In comparison, tree map is intended for the visualization of hierarchical data in the form of nested rectangles, but both charts show ratios of each part to the whole. For tracking the trends, line charts are frequently used. The following example shows a trend or pattern of the server CPU load by days in a week. By adding more than one lines, we can see a comparison between the trends of different objects. Also, on the right side of the slide, by specifying the area between or under the lines, we have the standard area chart. Different from a stacked area chart, in a standard area chart, each variable is independent and non-cumulative, which means that they don't add up to 100%. In this chart, we can imagine that the blue area actually shaded the red area, and the red area shaded the green area. This is best used to show or compare a quantitative progression over time. In cases where many data series are to be graphed, a line chart is usually a more legible choice. To analyze data distribution and the relationship between datasets, scatter charts are very useful. The following scatter chart shows the relationship between the weight and height parameters. It is not absolute, but from the chart we can see a pretty strong positive relationship between these two parameters. Besides, to show the relationship and distribution, box charts, bubble charts, heat map charts, and polar charts are also good choices. Details of those charts will be shown in the following slides. Box chart represents of data based on the minimum, first quartile, medium, third quartile, and the maximum. Also, outliers can be easily told from the box as individual points. Bubble chart is considered a variant of scatter plot. Instead of representing the data via dots, A bubble chart represents data with bubble that not only shows the location in the coordinate system, but also its size. Polar chart is a chart drawn in the polar coordinate system. It is useful when relationships between data points can be visualized most easily in terms of radiuses and angles. Heat map is a data table with rows and columns denoting different sizes of categories. This chart is also a good resource for comparing data. There are a lot of information you may want to visualize geographically, such as the number of cases of COVID-19, the support rate of president election, etc. The following example shows a choropleth map of the United States presidential election in 2008, which is optimal to show the distribution of geographic related data. Thanks for watching this video. Now please go through our notebook step by step for a better understanding of today's content.